Financial derivatives and stable value currencies. Financial derivatives are the most common application of a smart contract, and one of the simplest to implement in code. The main challenge is in implementing financial contracts is that the majority of them require reference to an external price ticker. For example, a very desirable application is a smart contract that hedges against the volatility of either or another cryptocurrency with respect to the US dollar. But doing this requires the contract to know what the value of ETH/USD is. The simplest way to do this is through a data feed contract maintained by a specific party, for example the Nasdaq, designed so that that party has the ability to update the contract as needed, and providing an interface that allows other contracts to send a message to that contract and get back a response that provides the price. So that's the idea of Oracle. Since the blockchain, Ethereum blockchain, is a state machine that is deterministic, it cannot get data from the outside. It can only do calculations, computations that have always the same result, and is only using data that is sent in through a transaction or through the current state. Therefore, the price has to come from the outside. So somebody has to basically call into a contract this reference price contract and update the state of the ETH/USD pair. Now, given that critical ingredient, the hedging contract would look as follows. Wait for party A to input 1000 Ether. Wait for party B to input 1000 Ether. Record the USD value of 1000 Ether, calculated by querying the data feed contract in storage. Say this is X. After 30 days, allow A or B to reactivate the contract in order to send X worth of Ether, calculated by querying the data feed contract again to get a new price to A and the rest to B. Okay, how does it work? Okay. What kind of contract is that? So A and B put 1000 Ether, and then the current price is X, and then we activate the contract in order to send X worth of Ether. What's a weird contract? I don't understand. It's not a swap. It's not a call. It looks like a future. I don't know. Such a contract would have significant potential in crypto commerce. One of the main problems cited about cryptocurrency is the fact that it's volatile. Although many users and merchants may want the security and convenience of dealing with cryptographic assets, they may not wish to face that prospect of losing 23% of the value of their fund in a single day. Up until now, the most commonly proposed solution has been issuer-backed assets. The idea is that an issuer creates a subcurrency in which they have the right to issue and revoke units, and provide one unit of the currency to anyone who provides them offline with 1 unit of a specified underlying asset. Yeah, it's a stable coin, so 1 for 1. Basically, whenever you give them 1 USD, they keep it in their storage and they create 1 crypto USD. So that's Tether. The issuer then promises to provide 1 unit of the underlying asset to anyone who sends back 1 unit of the crypto asset. So if you want to redeem, if you want to reconvert your Tether, you burn that Tether and they give you 1 USD. This mechanism allows any non-cryptographic asset to be uplifted into a cryptographic asset provided that the issuer can be trusted. Obviously, if they run away with all the real USD, then you're out of luck. In practice, however, issuers are not always trustworthy. Well, you bet. And in some cases, the banking infrastructure is too weak or too hostile for such services to exist. Financial derivatives provide an alternative. Here, instead of a single issuer providing the funds to back up an asset, a decentralized market of speculators betting that the price of a cryptographic reference asset will go up plays that role. Unlike issuers, speculators have no option to default their side of the bargain because the hedging contract holds their fund in escrow. Okay, that's why each guy puts 1,000. So depending on whether it goes up or down, one guy is gonna be winning and the other guy will be losing. Note that this approach is not fully decentralized because a trusted source is still needed to provide the price ticker. Although arguably even still this is a massive improvement in terms of reducing infrastructure requirements. Unlike being an issuer, issuing a price feed requires no licenses and can likely be categorized as free speech, and reducing the potential for fraud. So what they say here is that if you do the business of storing USD, you'll be falling under the law about money or something. I'll forget the stuff, the name. But you need a license for sure. Money exchanger, something like that. You need a license, or bank to even a stronger license. And most of the time, since the government does not like cryptocurrencies, it's gonna be hard to get that license. But if you just provide a price, this is not essentially storing any asset or value. Identity and reputation systems. The earliest alternative cryptocurrency of all, Namecoin, attempted to use a Bitcoin-like blockchain to provide a name registration system, where users can register their names in the public database alongside other data. The major cited use case is for a DNS system, mapping domains like bitcoin.org, or in Namecoin's case, bitcoin.bit, to an IP address. Other use cases include email authentication and potentially more advanced reputation systems. Here is the basic contract to provide a Namecoin-like name registration system on Ethereum. And then you have a function called register that takes name and value. Okay, it simply says that the first guy who has the name and wants to store a value will get it, because afterwards this guy would not be null, and then this test will fail. So this contract is very simple. All it is a database inside the Ethereum network that can be added to, but not modified or removed from. Anyone can register a name with some value, and that registration then sticks forever. A more sophisticated name registration contract will also have a function clause allowing other contracts to query it. What do you call it? A function clause? I don't know. As well as a mechanism for the owner, the first register of a name, to change the data or transfer ownership. One can even add reputation and web of trust functionality on top. Okay, that's pretty simple. Decentralized file storage. Over the past years, there have emerged a number of popular online file storage startups, the most prominent being Dropbox, seeking to allow users to upload a backup of their hard drive and have the service store the backup and allow the user to access it in exchange for a monthly fee. However, at this point, the file storage market is at times relatively inefficient. A cursory look at various existing solutions shows that, particularly at the uncanny valley of 200 gigabytes level, at which neither free quota nor enterprise level discounts kick in, monthly prices for mainstream file storage costs as such that you are paying more than the cost of the entire hard drive in a single month. Okay. Ethereum contracts can allow for the development of a decentralized file storage ecosystem. I think actually they have been trying to do that. There's a interplanetary file system now, where individual users can earn small quantities of money by renting out their own hard drive, and unused space can be used for further drive to further drive down the cost of file storage. Okay, so how would it work? How would that work? The key underpinning piece of such a device would be that we have termed the decentralized Dropbox contract. This contract works as follows. First, one splits the desired data up into blocks, encrypting each block for privacy, and builds a Merkle tree out of it. One then makes a contract with the rule that every n blocks, the contract would pick a random index in the Merkle tree. So actually, I think that this is not possible at the moment, because the contract per itself will not activate. So this is a white paper, so that's fine, but there's a problem here now. We pick a random index in Merkle tree using the previous block hash accessible from contract code as a source of randomness, and give X ether to the first entity to supply a transaction. Or maybe it means that it's the other way around. So if you know that guy activates, then you can query it and give it some money. So that would work, except that you would have, if you are a guy storing data, you would have to check if we are picked or not. And give X ether to the first entity to supply a transaction with a simplified payment verification, like proof of ownership of the block at that particular index in a tree. Okay, so the idea here is that if you know that you're the guy who needs to, so they pick one block in random, and if you happen to know that, then you give the Merkle proof that you actually have it. When the user wants to, so that checks that at least somebody somewhere. Well, this is actually kind of weird, because if you want to supply the transaction like this, you will still need to provide that particular block. So you provide the block and you provide the Merkle proof, but it's kind of, it wouldn't work if you just provide the hash, because everybody can store the entire Merkle tree hash and not actually store the data. When the user wants to re-download their file, they can use a micropayment channel protocol. Pay 1 zeble per 32 kilobytes to recover the file. The most fee-efficient approach is for the payer not to publish the transaction until the end. Okay. Instead, replacing the transaction with a slightly more lucrative one with the same nonce every 32 kilobytes. Okay. So the idea here is that you get the file data from that some guy who has it, because the data would not be on the chain. That would be crazy to have all this data on the chain. So off the chain, people store the data, and you query, so offline, right? Off chain, you query them, and they give you that block. Once they give you that block, you reward them with a transaction that has 1 sabo. But 1 sabo is ridiculously small, so you don't want to, the fee would be higher than that. So you actually give them the transaction on the premise that they will not be interested in the caching in so little. So they are incentivized to give you another block, and then you replace a transaction, or you give another transaction now with 2 sabo, and so on and so forth. So if at one point they give you a block and then you refuse to pay, then they would just cut, and they just lose 1 block, 132 kilobytes. So at the end of the day, you would have all your file. If you try to cheat, then they would stop giving you the data, and they are just cheated by off 1 sabo. So that's pretty okay. That's okay. An important feature of the protocol is that although it may seem like one is trusting many random nodes not to decide to forget the file, okay, one can reduce that risk down to near 0 by splitting the file into many pieces via secret sharing, and watching the contracts to see each piece is still in some node's possession. if a contract is still paying out money, that provides a cryptographic proof that someone out there is still storing the file. Okay, so that there's actually not much more that it says before, right? Because you always okay. So only addition here is this secret sharing part, which kind of means that you over storing the file. You split the file into pieces, but you kind of make if you just split into pieces like that, and then you're unlucky, then one block is not available anymore because nobody has it, then your file is toasted. But what they say here is that you split the file into pieces, but you have a rule that to decrypt, to get a piece, you need, for example, one of 2 copies, and you're overpaying for the storage, but it is like redundancy. Decentralized autonomous organizations. The general concept of a decentralized autonomous organization, so it's DAO, is that of a virtual entity that has a certain set of members or shareholders, which perhaps with a 67 majority have the right to spend the entity's funds and modify its code. The members will collectively decide on how the organization should allocate its funds. Methods for allocating a DAO funds could range from bounties, salaries, to even more exotic mechanisms, such as an internal currency to reward work. This essentially replicates the legal trappings of a traditional company or non-profit, but using only cryptographic blockchain technology for enforcement. Okay, so far much of the talk around DAOs has been around the capitalist model of a decentralized autonomous or corporation with dividend receiving shareholders and tradable shares, an alternative perhaps described as a decentralized autonomous community. Would have all members have an equal share in the decision making and require 67% of the existing members to agree to add or remove a member. The requirement that one person can only have one membership would then need to be enforced collectively by the group. Okay, I see the stuff, but I don't see how you do the last requirement, because since anybody can create an address, I don't. Okay, let's see how they solve that problem. A general outline for how to code a DAO is as follows. The simplest design is simply a piece of self-modifying code that changes it if 2/3 of members agree on a change. Right? That's actually what they're doing in these government coins. Yeah, they put a project and then they emit a token, and if you have enough token devote a change, then the contract can be modified. Although code is theoretically immutable, one can easily get around this and have de facto mutability by having chunks of the code in separate contracts and having the address of each contract to call store in the modified storage. Yeah, it's like a table of pointers, basically. It's kind of common. So a table of pointers to functions. In a simple implementation of such a DAO contract, there would be 3 transaction types distinguished by the data provided in the transaction. Okay, OIKV to register a proposal with index I to change the address, I to register a vote, and 2I to finalize. So this is basically the two-phase commit protocol. So first you start to propose a change, then you do you collect the votes, and then you say that the vote is over, and then the stuff will decide whether the proposal goes through or not. The contract would then have clauses for each of these. Okay, they call contract clause, but it's actually like a function. It would maintain a record of all open storage changes, along with a list of who voted for them. It would also have a list of all members. When any storage change gets 2/3 of members voting for it, a finalizing transaction could execute a change. A more sophisticated skeleton would also have a built-in voting ability for features like sending a transaction, adding members and removing members, and maybe provide for liquid democracy. Start vote delegation, i.e. anyone can assign someone to vote for them, and assignment is transitive. So if A assigns B and B assigns C, then C determines A's vote. The design would allow the DAO to grow organically as a decentralized community, allowing people to eventually delegate the task of filtering out who is a member to specialists. Although unlike in the current system, specialists can easily pop in and out of existence over time as individual community members change their alignments. Okay, so it's a bit of hand waving, but so it's basically once you have a voting system, then you can do a bunch of crap. An alternative model is for decentralized corporation, where any account can have 0 or more shares, and 2/3 of the shares are required to make a decision. A complete skeleton would involve asset management functionality, the ability to make an offer to buy or sell shares, and the ability to accept offers. Preferably with an order matching mechanism inside the contract. Delegation will also exist. Okay, so all this stuff kind of would work, right? But I think in practice it didn't really happen because of the cost. Like for example, when they say that there could be an order matching mechanism inside the contract, that would seem to imply you could do an exchange, but that would be fairly slow to match orders. And also a lot of storage will be required. So so again, it's a white paper, so they definitely can put all the ideas, even if they are not all of them are implementable or implemented or implementable. Further applications. Okay, so let's finish with this section. And saving wallets. Suppose that Alice wants to keep her funds safe, but is worried that she will lose or someone will hack her private key. She puts either into a contract with Bob, a bank, as follows. Alice alone can withdraw a maximum 1% of the funds per day. Bob alone can withdraw a maximum 1% of funds per day, but Alice has the ability to make a transaction with her key, shutting off its ability. And Alice and Bob together can withdraw anything. Okay. So it's like two account that has 2 signatures required. So it's a multi-sig account. So if you have 2 signatures, you can withdraw anything. But if you only have 1 signature, you have a cap of 1%. Except that, and also Alice can shut off Bob. So the idea that if Bob is misbehaving, then she will be stopped by Alice once she notices that Bob withdrew 1% without her consent. And if Alice is hacked, then the hacker will only be able to withdraw 1% a day. So then she would meet Bob and then withdraw all the rest in one go. Right. So normally Alice would use her 1% a day. So normally 1% per day is enough for Alice. And if Alice wants to withdraw more, she can contact Bob for help, right? Because together they can withdraw anything. And if she gets hacked, she runs to Bob to move the funds to the new contract, right? So why? Okay, she means hacked, but she still has the key, right? Somebody else has the same copy of the key, but then that person can steal 1% max. She notices that, and together with Bob, she moves everything out. Now she loses her key, so she cannot do this anymore. So Bob can withdraw 1%, and then after 100 days, he gets all the money. Okay. Crop insurance. One can easily make a financial derivative contract by using a data feed of the weather instead of any price index. If a farmer in Iowa purchases a derivative plays out inversely based on the precipitation, then there's a draw. Okay, so this is the same really as the hedging contract that was above, but instead of using the Oracle giving the price of Ether versus USD, you use Oracle that gives the precipitation, it's a weather channel or something. A decentralized data feed. For financial contracts for defense, it may eventually actually be possible to decentralize the data feed via a protocol called shilling coin. Never heard of that. Shilling coin basically works as follows. And parties all put the system the value of a given datum. Okay. The values are stored, and anyone between the 25th and 70th percentile gets one token as a reward. Okay, so basically you all suggest what you think the price of ETH/USD is, and if you are in the supposedly if you are in the center, so in the between 25 and 75 percentile, then you are in just around the median 50%. Everyone has the incentive to provide the answer that everyone else will provide, and the only one in the large moment can this creates a decentralized protocol that can theoretically provide any number of values, including yeah, I think people don't do that because it would be all this stuff would have to be stored and put in the storage. Smart multi-signature is Crow. Bitcoin allows okay, Bitcoin allows multi-signature transaction contracts where, for example, 3 out of given 5 keys can spend the funds. Ethereum allows for more granularity. For example, 4 out of 5 can spend everything, 3 out of 5 can spend 10% a day, and 2 out of 5 can spend 0.5 a day. Additionally, Ethereum multisig is asynchronous. Two parties can register the signature on the blockchain at different times, and the last signature will automatically send the transaction. So actually, they say that they don't in Bitcoin. The BT signature thing is a built-in operator of the scripting language, and in Ethereum you don't need to do that because you actually can write a program that has this logic. So if people send transactions to that particular contract, it would gather the signatures and determine how many signatures you got, and decide whether how much or whether you're allowed to spend, and if not 100%, how much you will be allowed to spend. So I think that's actually how BTC works. Cloud computing. The EVM technology can also be used to create a verifiable computing environment, allowing users to ask others to carry out computation and optionally ask for proof that computation at certain randomly selected checkpoints were done correctly. This allows for the creation of a cloud computing market where any user can participate with their desktop, laptop, or specialized server, and spot checking together with security deposits can be used to ensure that the system is trustworthy. Although such a system may not be suitable for all tasks that require high-level interpersonal communication, for example, cannot easily be done by a large cloud of nodes. Other tasks, however, are much easier to parallelize. Projects like Study at Home, Folding at Home, and genetic algorithms can easily be implemented on top of such platforms. Okay. I think the challenge here is the verifiable part. Yeah, I didn't really explain how that would work. Because basically it means that the contract would be able to verify that the computation is correct, and the question is also how when you want to provide the result, well, you don't want to provide the result to the transaction basically, because then every transaction will contain possibly a large data set. And without that data, how can the contract verify that the computation result is correct? So I don't know. Maybe depends on the computation requested. Peer-to-peer gambling. Any number of peer-to-peer gambling protocols, such as Frank, Strajano, and Richard Sabadice, can be implemented on the Ethereum blockchain. The simplest gambling protocol is actually simply a contract for defense on the next block hash, and more advanced protocols can be built from there, creating gambling services with near zero fees that have no ability to cheat. Also, this is for sure implemented somewhere. Prediction markets, provided an Oracle or shilling coin prediction market, are also easy to implement. And prediction markets together with shilling coin may prove to be the mainstream application of Futurarchy as a governance protocol for decentralized organization. So this is actually the same idea as they say up there, shading coin, yeah. Except that it's not only it's only like now, but you also do the future. Basically, you use that as the reference, and then at some point in the future, you will use that reference and see how far the guy is from and whether he can exercise or not. So if whenever you want, you can use something for spot, you can use for derivatives. So on-chain decentralized marketplace using the identity and reputation system as a base. Okay, that's pretty interesting. Miscellaneous and concerns. Okay, so let's stop here because we are after the applications, and this next section will be about like complexity of implementation, or some details are not super important, but we're still going to take a look at that because it's always tricky in the details.